Okay. Good morning, everyone. How are you? Thank you for taking the time and joining us for the Microsoft ATA deployment session. In this session, we'll talk about Microsoft Advanced Threat Analytics and the thing that you need to do before deploying that, and also how you're going to deploy that. I'm not sure if some of you saw the announcement we had about Azure ATP. Did you? Some of you? Great. So we're not going to talk about Azure ATP in this session. We'll just cover that briefly, and we'll focus on the on-premises ATA. Now, before we start, maybe we'll meet you a bit. So how many of you are familiar with ATA? Great. So don't talk a lot about ATA this time.
Okay.
How many of you have ATA deployed in your network? Great. Not so much. So you learn about that in this session, so it's great. Last question. How many of you work in an organization that was breached this year? OK, not a lot of honesty here. So let's try that. How many of you have friends that work in an organization that were breached this year? Oh, that's better. Yeah, great. OK, so let's get started.
You want to introduce yourself?
Yes, I did introduce myself. Sorry, my name is Gal Zuberstein. I'm program manager at the ATA product team, working on all the different aspects of the product and Azure ATP now as well. Astrid here with me.
Hello, I'm Astrid McLean. So I'm on the ATA product team as well. Gal works in Israel. I work in Redmond, despite the Australian accent. So today, together we're going to talk about how to deploy ATA. But I know not everybody knows everything about ATA, so I'm just going to do a very brief introduction to what ATA is. So following on from Gal's question, I'm going to quote a former FBI director that says there are only two types of companies, those that have been breached and those that are going to be breached. So at some point, despite all the effort we put into perimeter defenses and strengthening our identities and those sorts of things, at some point the attacker's going to get behind all of that and they're going to get into your network. And we know from our investigations, we know from real customer events that attackers tend to spend around 100 days in an environment before they're even detected. So during that time, they're mimicking a lot of the stuff that your user's doing. They're trying to stay under the radar, they're trying to stay very invisible, and they're trying to get control of your network. And that's where ATA can help. So ATA is designed to alert you to those attacks, to try and find those attackers before they do any damage in your environment. Now, the way it does that, it has two techniques for doing it. So the first one is around behavioral analysis. So we look at the network traffic, specifically the network traffic that's coming from your domain controllers, and we effectively profile your environment. We're looking at the users, we're looking at the computers, we're looking at the entities in your environment, trying to understand what's normal so that we can see the stuff that's abnormal and alert you to that. The second thing we do is we actually look at real attacks that we've seen in the wild, attacks that our security researchers have been researching, and we have detections designed to find those things. We know that attackers will try and steal your AD database. So a replication from a non-domain controller is something that stands out. We know they can do things like put a golden ticket on your domain controllers to try and gain domain dominance in your environment. We know what those things are, and we can find them. But it's a combination of both of those things, both knowing the attack techniques as well as the behavioral analysis, and that combination of those allows us to drive down the false positive rate of alerts and allows ATA to be far more effective and only show you the alerts that you really need. And those detections cover kind of the span of the cyber kill chain, so everything from reconnaissance to compromised credentials to lateral movement all the way to domain dominance. Now, we're not going to cover all of the detections in this session. What we're going to do is explain how ATA works and how you can deploy it. And at the end, we'll point you at a session that's immediately after that that'll go through the kind of the attack chain and show you how an attack works and how ATA can bind it. So how does ATA work? There are two main components in ATA. So the first one is the ATA center. That's really the brains of the operation. That's where all the detections happen. So that's where we get the parsed network traffic. We do the detections. We do the profiling of entities. We go out and, we need to truly understand what Astrid as a user has been doing in the environment to do the right detections. So when you connect to the ATA console, you're actually connecting out to the ATA center. When we have alerts, we can send them from the ATA center. We can send alert notifications via email to you, or we can send them via syslog to your SIEM system as well. But the other major component of ATA is the gateway. And these gateways come in two varieties. So the first one is a lightweight gateway. So this is a service that runs directly on your domain controller. It's looking at the network traffic going in and out of the domain controller. It parses it. It goes and does kind of name resolution on the IP addresses we see. It also automatically collects certain Windows events from your domain controllers that are important to us for our detections. But we know that domain controller is the heart of Active Directory. It's very precious to every DC operations person. So we have a resource limitation function in the lightweight gateway service. That resource limitation function has a look at the free resources on the domain controller, and we try and make sure there's always around 15% free resources. If we see that go down, if the domain controller gets particularly busy, we will limit the resources that the lightweight gateway service actually can take and make sure that we will take the pressure rather than doing anything to the domain controller. There is a consequence to that though. If we have too few resources for the lightweight gateway service, we'll stop parsing traffic. So sizing is very important when you're looking at putting a lightweight gateway in, and I'll talk about sizing after I talk about the architecture. Now the second type of gateway you can have is a standalone gateway. So here you can connect one or more domain controllers to your ATA gateway by sending the traffic via port mirroring or a network tap so that the gateway can see the domain controller traffic without actually running on it. Now we do need more than just the gateway traffic. We still need those events. So for the standalone gateway, you need to either set up Windows event forwarding. So you can set up Windows event forwarding from your domain controllers through to the gateway to send us the events we need. Or if you're already gathering that information from a SIEM system, we can also get those Windows events directly from a SIEM rather than you having to do the Windows event forwarding. Now in this configuration in your environment, you can have, as many, you can have lightweight gateways everywhere, you can have a combination of lightweight gateways and gateways, or you can have all gateways, it's up to you. The other source of information we have is actually from VPN services as well. So we will accept radius accounting data that gets sent to the gateways, and that gets used to help with our detections as well. So that's the other piece of information that we need. So now that we know how it works, let's talk about what you need to do to plan your deployment. First thing you need to do is size the environment. So whether it's a proof of concept or a production environment, you should be doing sizing of your environment because that's critical to make sure that ATA works as expected. And we give you a nice handy tool that you can download to do that for you. So you download this tool, you run it on a domain-connected workstation. As long as that workstation has network access to your domain controllers, the user running it needs to be able to run performance counters on the domain controllers as well. And it goes and collects packets per second information from your domain controllers. And it does that for about a 24-hour period. And what it gives you in the end is it actually gives you a spreadsheet. I'm standing too close to you. Oh.
I'll move away.
Okay. All right, so let's have a look at the spreadsheet that you get. Or maybe I'm standing too close to the speakers. This is a spreadsheet you get from a sizing tool. So this is something we got from a real customer. We've changed the names to protect the innocent. But it'll tell you things like the number of domain controllers you've got. It gives you a start and end time of when you ran it. So it runs by default for 24 hours. You should run this during normal work periods. So if you're a Monday to Friday kind of business, don't run it on the weekends. You won't get all the traffic that you're expecting. So the first thing we can see is the sizing for the center. So if we go and have a look at what we measure, we manage the maximum packets per second, the average, and the busy across all your domain controllers. The maximum packets per second is actually not as interesting as you think because they can be spikes. What we're really looking at is the busy packets per second. That's how we size the CPU and memory. The way we look at busy packets per second is we have a 15-minute sliding window that we look across your domain controllers while we're doing the sizing, and we're looking for the busiest 15 minutes. So it gives us a true indication of what those peaks are rather than just those one-off peaks. So that maximum packets per second will drive the CPU and memory. The average packets per second across your domain controllers will drive the storage requirements because we do store data on the ATA center And so we give you recommendations here in the tool. The other thing we want you to look at is the individual domain controllers. So here we're looking for whether the domain controller can support a lightweight gateway. So there's a few things you can look at. Obviously, if the tool didn't run on that domain controller, you may need to run it again. If this operating system is unsupported, so this is a 2003 DC, we only support 2008 R2 and above. But if the domain controller supports from an operating system point of view, we'll also look at how busy that domain controller is, as well as the packets per second, and give you recommendations about whether you might need to add extra resources to the domain controller in order to run the lightweight gateway. You'll notice every now and then we'll say, no, you can't run it here. If we have a look here, you can see the packets per second are well above the 10,000 packets per second we officially support for any domain controller to run the lightweight gateway. So in that case, you'll need to use a standalone gateway if that's the true measurement for that domain controller. But do have a look at the busy packet start and end time, because that will give, you might want to think about whether there's something else running on the domain controller during that period of time to make sure it's an accurate measurement. And then the last one I'll show you, so we have this great one that says maybe, which is a, hey, you're close, but not quite close enough. So for this one, it's just over 10,000 packets per second. So it might support it with the right resources, and we have a contact in the tool that says, hey, you can email us and talk to us about what the sizing might be appropriate for that domain controller as well. Okay, so that is the lightweight gateway sizing tool, or the ATA sizing tool. Oops, I get the wrong number. I got the wrong number. And over to Gal to talk about some deployment.
I'll get far from the microphone.
I'll turn mine off.
OK, so now that we have our sizing guidance, the next thing that we have to do is decide some other things, some other design decisions that we need to make sure are in place before we're actually deploying. So let's start with the ATA center. The first thing that we'll have to think about is whether we want to deploy it as a physical server, as a virtual server, or even as an IaaS VM on Azure. All of them are great possibilities, or all of them are supported. And we really see that customers choose the different options based on their size. So very large customers will go for the physical server and will dedicate an entire server just for the ATA center. And it makes sense because it makes the ATA center like an appliance. And there's a lot of security products that work that way. Once we decided, the next thing up, we'll have to decide whether we're deploying the ATA center in workgroup environment or a domain environment. Everyone knows that domain environments give us better management, but also the domain admins will always be able to access the center machine, and it's not always good for all of environments. So we support workgroup environments as well. And the last thing that we'll have to choose is whether we're using certificates that are issued by our corporate certificate authority or self-signed certificates that will be generated as part of the deployment. Now, who thinks that certificates that are generated by corporate CA are better? All right, not all of you. So we recommend that you deploy in production environment always corporate certificates, like certificates that are issued by your corporate CA. But for lab environment, you can always choose to use self-signed certificates just to speed things up and don't have to have the CA approval process, which may be lengthy in some organizations. OK, so now we decided everything that we need, and we can go ahead and really deploy the ATA center. So you should know that you'll need one ATA center for every Active Directory forest that you have in your environment. So it means that if you have 4 Active Directory forests, even if they're trusted or whatever, you'll need 4 different ATA centers as of today. We are working on supporting multi-forest environments on the same ATA center, but this is still work in progress and nothing that, I don't have an ETA for that even, so it will take us some time. Then you'll need to decide whether you'll deploy the center on Windows 2012 R2 or 2016. Both are good. And as part of the deployment process, which is basically next, and finish, so I won't show that to you, But basically, as part of the deployment, we'll deploy the ATA Center service together with all the underlying components that we need. An example is Mongo database, which is the underlying database for ATA. And it's automatically managed by ATA. You don't need a Mongo database DBA in your organization. Everything is taken care of by ATA. OK, so as I said, the deployment is next, and finish. But there's few things that you should keep in mind and stop for a second and think. So first of all, we talked about the certificate, as I said. A good hint about the certificate will be to use web server certificate templates, which are compatible with the ATA requirements. The more detailed requirements are documented in our documentation. We'll share some links later with you. The next thing, which is actually a post-deployment thing, is to configure the ATA user account that will be used to read all the information from Active Directory. So you should know that this account should be a regular user account with read-only access to Active Directory, not a domain admin, nothing special, just a regular account. You do need to make sure that you give this user account read permissions to the deleted objects container of Active Directory, because we use that information as well as part of the product. OK, so we're good with the center. And the next thing we'll have to talk about is the gateway. And as Astrid mentioned, the most important thing, or the major decision that we'll need to make, is whether we're using lightweight gateway or standalone gateways. We can combine. You can decide to have all your branch offices covered with lightweight gateways and your main offices with standalone gateways. But it is an important decision. We are seeing customers that are more secured, let's say, that prefer the standalone gateway just to reduce the footprint of ATA from the domain controller. So it will be harder for attackers to know it's there. But at the end of the day, most of our customers today use lightweight gateway. It's like 80-something%. For the gateways, you see here that I wrote, you need to decide on your certificate type. But actually, from ATA 1.8, there's nothing to decide, because we're using self-signed certificates. These are used for mutual authentication for the communication between the gateway and the center. And all of these certificates are managed automatically by ATA. Just if you encounter this kind of certificates on your domain controllers, don't delete them, don't do nothing to them, because it will break your gateways. And the last thing that we'll need to make sure is that the events, which are another important data source, get to the gateway. So if we're using lightweight gateways, then it will be collected automatically. All the events will be collected automatically by the lightweight gateway. But if we're using standalone gateways, you'll have to make sure to forward the relevant events to that gateway, either through syslog forwarding from your SIEM solution or through Windows event forwarding that will be set up just for ATA. Lightweight gateway.
Just switch myself back on. All right, so installing a lightweight gateway. It is pretty much next, but there are a few do's and don'ts you need to be really aware of. So the first thing is it does rely on .NET Framework 4.6.1. So if that's already installed on your domain controllers, great. If it's not yet installed, install it first. It does require a reboot, and the last thing you want is an unexpected reboot just before you install the gateway. So install that first. If you're doing an unattended installation using SCCM, you can set it up as two separate packages that rely on each other, but that way you can schedule the reboot. The other thing is, when you're doing network monitoring on your domain controllers that are running the lightweight gateway, you can use Netmon, you can use Wireshark, but you can't use Message Analyzer. The reason for that is we actually use some of the Message Analyzer code as part of the way we parse the network traffic with the lightweight gateway traffic, and if you install Message Analyzer, it will interfere with that. But what I'll do is I'll switch over to my demo machine. I'll show you how easy it is to deploy a lightweight gateway. All right, so here I am at the ATA Center. So you can see, oh, I've clicked on it again. You can see we have this very helpful banner that says, hey, you need to set up the user ID and password that Gal talked about. And we have to download a gateway setup. So it takes me into the configuration under gateways. I can simply download the gateway setup and save that somewhere. So you'd save that and copy it to a domain controller. And because this is a demo, that's something I've done earlier. And here's my domain controller. And so what I've done is I've copied that gateway setup package, and the zip file has 2 files in it. So one is the actual setup files. The other is a JSON file that actually has the information about how to connect back to the ATA center. So those gateway setup deployments are specific to an ATA center. So I'll kick off the deployment. And like all good things, it pops up and it says, hey, what language do you want this to be in? I'll pick English today. It automatically decides whether it's going to be a gateway or a lightweight gateway because it knows what it's running on. Here it knows it's running on a domain controller, so it'll install lightweight gateway. If you try this on a normal server, it'll install a gateway. So we go through next, you get an installation path and you hit install. Now in terms of storage on the lightweight gateway, you don't need a lot of storage because all we're really storing there are the binaries for the service and the logs themselves. But to make sure you've got enough room for the performance, kind of the performance logs as well as the troubleshooting logs, you need somewhere between 5 and 10 gig of space where you install the lightweight gateway service. The other thing we do while we're installing that is we install 2 services on the machine. So we install the gateway service and we also install a gateway updater service. Because what happens is if you have to make any updates on the center, we use the updater service to automatically update the gateways as well. Now, like all good things, it's a configuration option, so you can either decide to automatically update the gateways, or you can set them to update manually, and you can kind of select them, but it's the updater service that will do that. The other thing you need to do on your domain controllers is you need to open up some network ports through to your endpoints. So as part of the parsing process, we parse the network traffic, and then we do a patented name resolution process, where we actually look at what devices are behind the IP addresses. So you need to open up NetBIOS and NTLM over RPC so that we can do that name resolution. So it means in the detections, rather than just having an IP address, we actually know something's happened with my, Astrid's machine, not just some random IP address, which makes it much more difficult to do. The last thing you have to do, and as soon as this is finished, and demos always take longer than you think, the last thing you have to do is on a lightweight gateway machine, you have to decide which of your lightweight gateways will be a domain synchronizer. So the domain synchronizer gateway is the one that actually connects to AD and gets user information, group information, that sort of stuff. So it does get that information slowly using that ATA user account that we set up. When you set up gateways, it automatically tells you, it automatically sets it up as a domain synchronizer. With a lightweight gateway, you actually have to specify one. And as soon as this sets up, which it hopefully will, any second now, we can turn it into a domain synchronizer. What do you think? Are we going to wait for this? Should we go back?
We can get back to that, I think.
I think we'll get back to that in a little bit. So we'll show you what happens in the center. Oh, look, it just finished. Look, it's like a watched pot. So I'll go back to my center and show you what that looks like. And see, you can see that's my Contoso domain controller. When I click on it, it actually gives me this option right here to say, hey, I want to make that a domain synchronizer candidate. And we're done. I've now deployed my lightweight gateway. Okay, Gal, how does that look like for a gateway?
Well, it's actually almost the same. The do's and don'ts.
I don't think your mic's on.
Can you hear me now? Yes. Sorry. So the do's and don'ts for the gateway are roughly the same, like with the lightweight gateway. As we said earlier, gateway and lightweight gateway share basically the same code. So all of the things will be basically the same. Like, don't install message analyzer. Make sure that you have all the open ports that are needed for name resolution, all of that. One thing that is different is that in a gateway case, we need to use port mirroring. So in that case, we'll need to make sure that we have at least 2 network adapters on the machine. One will be dedicated for the port mirroring. We call that the capture network adapter. And you have to configure port mirroring both for inbound and outbound traffic to the domain controller, to and from the domain controller. Now, before you install the gateway, just make sure to validate that the traffic from the domain controller actually reaches the gateway. Simply install netmon or Wireshark on the gateway, start a capture on the capture adapter, and look for the domain controller traffic that should be there. OK, so at this point, basically, we learned how to deploy ATA. By this time, you should have everything, all your domain controllers covered. And the next thing that we want to do is to validate our deployment, make sure that we did everything right and that we don't have any issues. So the first place to look will be the health area that we have inside the product. In that area, whenever there's an issue, a health issue, there will be a monitoring alert that will flag you that something is wrong. We can also send you emails if something is wrong. The alerts will be something like if a gateway is out of memory, if the center has not enough resources, all of these kinds of alerts. So this will be the first place to look for. Now, if you have a bigger thing that like ATA doesn't work completely, you'll want to review the logs that are located. You can see the passes on the screen. Those are textual logs, much more verbose, and you can quickly identify what's going on. Also, we have a dedicated article of known errors that we have in the product that maybe if you encounter, you can take a look and make sure to fix your error. OK, the next thing we'll have to validate is event collection. ATA requires some specific events for its different detections. So we have a dedicated ATA auditing tool that will go ahead and look for the required configuration of your domain controllers to make sure that your group policies are configured right for ATA. And after you run this tool, basically, the lightweight gateways can just go ahead and collect all the events from your domain controllers. Now, if you're using Windows event forwarding for the gateway, then we'll have a dedicated code snippet that you can run to make sure that the events flow as expected. Now, at this point, we're ready, but to really believe that ATA works, we'll want to simulate some alerts and make sure that everything works.
All right, so, whoa, switch the machine. Can't see what I'm doing. No, you can hang on to that. So one very, very quick detection we can do, just to make sure that your domain controllers are talking to the center so you can see things, is if I do an NS lookup, DNS reconnaissance is something that a lot of attackers will use just to try and see what's happening in your environment. And so here, all I've done is I've done a dump of my contoso.com. And you can see that actually the transfer didn't work. It was refused. But the fact that I tried a DNS reconnaissance is something that ATA will pick up. So we'll have a look at our ATA center. And in just a moment, hopefully, that'll say updated. Are the demo codes with us? That's kind of one we created earlier. It should turn up. You never know. We've been kind of deploying the gateway back and forth. So, but that's generally speaking. I don't think it's going to update. All right. But that's the sort of quick test you can do to say, hey, if I do just an NS lookup against the domain controller that I've deployed a gateway against or a lightweight gateway, and then I'll be able to see it in the ATA center itself.
OK, so in a moment, the timeline will be updated. But this was an example for a real basic test. DNS reconnaissance is an example. Remote execution to the domain controller with PSExec is another example for a very simple attack. I'm not sure if it's even an attack that you can simulate to make your ATA functions. But usually, you'll want to have a deeper understanding of the attacks that ATA detects. And exactly for that, we published the ATA attack simulation playbook, which is a very, very detailed guide on how to simulate different attacks all across the kill chain, starting from reconnaissance, moving to lateral movement, privilege escalation, up to domain dominance. It's a very detailed document. It will help you get really into the mindset of attackers and really understand what they're trying to do and what they're trying to achieve as part of their campaign. So I highly recommend that you'll take a look at this playbook. It probably will be the last thing you'll want to do as kind of penetration testing before productizing ATA. Do remember that some of the alerts have learning time. The more sophisticated alerts require learning time. So make sure to have this required time. It's roughly 21 days before you simulate those attacks. And the last thing, that once the attacks will start to show up, usually you'll see things like, hey, there's a golden ticket showed up. So if you're not familiar with what golden ticket is or what you should do to triage that, you can take a look at our suspicious activity guide, which basically will tell you what is every attack, a quick description of the attack, and what are the steps you should do to quickly remediate it. And we have ATA ready.
OK. So the ATA console is not the only way that you can get data. So we've recently released a PowerShell module for ATA. So this does, you do need the latest version of ATA? You do need the latest version of ATA, which is version 1.8. To set it up, all you need to do is do an install module of advanced threat analytics. If you're using a self-signed certificate, you'll need to use the resolve ATA self-signed cert commandlet to deal with that. And if you're running it on the ATA center itself, you can just connect the ATA center URL to localhost. If you're running it remotely, you just connect it to the URL of your ATA center. So let's have a look at what some of these commandlets look like. So I'm back at my ATA center. And so one of the basic things I can do is just have a look at all the suspicious activity. So these are all the detections that I normally see on my console. And I can see all of the details of kind of all of those suspicious activities. Now that's a lot of detail, and this is PowerShell, so we like to tidy things up. So I can very easily use a PowerShell command just to get the information I need. And in this example, I've just listed all of the detections that happen to be on my ATA center. And they've got a list of whether they're high or low severity, whether they're open, closed, or suppressed, and the type of it. Now, if I want a few more details, for example, about that top, that passed the ticket attack, what I can do is I can start to look at information about a specific ATA suspicious activity. In this case, I'm going to access it via their ID. And you can see in this particular pass the ticket attack, in fact, all the pass the ticket attacks, it gives me a ticket source computer ID, it gives me a ticket destination computer ID, but it's a little bit obscure because it gives me a GUID. So what I can do here is if I want to start to get kind of more information, so one of the things I can do in PowerShell is actually download all of the details into Excel, and there's a way to download that. But what I'm going to do here is we have a series of PowerShell commandlets. So I'm going to get I'll select it again. I'm going to get that suspicious activity. I'm going to expand that list of source IDs for that pass the ticket. For every one of those, I'm going to have a look at the ATA unique identity or unique entity. It gives me more information about what ATA has about that particular entity. And then I'm going to pass it to an AD commandlet to see what AD has about that information. So for all of that, I can have a look and say, hey, that passed the ticket attack. The source of it was my admin PC. And I can get all the information out of AD about it that says, hey, this is a distinguished name, this is a SID, those sorts of things. So you can use PowerShell quite powerfully to combine the information from AD with a lot of other sources as well. OK. All right, so we've deployed everything, we've played with the console, you can use it with PowerShell. There are a few other configuration things you can do. I won't go through these in details, but you can exclude certain components. So if you have a security scanner in your environment that tends to trigger alerts, you can exclude them, those sorts of things. Honey token accounts, so if you're looking for an attacker to find that really craftily named user account like super user or SQL admin, you have no intention of using it in your environment, you add it as a honey token, and as soon as the attackers do anything with it, even if they log on, it will alert in ATA. The notifications, that was the email and syslog notifications that you can send out. And we have scheduled reports as well. So you can have reports on the summary of all of the things that happened in ATA, as well as things like users that have been added to sensitive groups. And you can schedule those reports on a daily, weekly, or monthly basis. And then we have a link there if you want to do a quick backup and recovery, just to make sure that you can back up the configuration of your ATA center so you can get it back up and running quickly. We've got some guidelines there as well. And we promised we'd talk just a little bit about Azure ATP, so I'm going to get Gal to talk about that very briefly at the end before we can take some questions.
Yes, so we really don't have a lot of time. So basically, Azure ATP, which we announced a couple of days ago in the keynote, is our new cloud offering that is bringing all the value that we have today in ATA, but offering it as a service, as a cloud service. The service is running on top of Azure. Maybe I'll just show you a quick demo of how it looks like. It basically looks a lot the same. So you can see here that I have this new page called Workspace Management. For Azure ATP, we'll have this concept of workspaces. And you can think of a workspace roughly as an ATA center, as an ATA deployment. So like you need ATA center for any Active Directory forest, you'll need a workspace for any Active Directory forest you'll have. And once I'll create my workspace, I can just browse the specific workspace, and you can see that it looks pretty much the same like ATA looks today. So if you're familiar with ATA, you should be pretty much familiar with Azure ATP as well. Going forward, we'll bring a lot of more value to Azure ATP, and since we'll be a cloud service, we'll be able to move really fast as well and add a lot of content really, really fast, and not just in a 6 to 12-month cadence like we're doing today with ATA. We're super excited about Azure ATP. You should also, if you're interested to try it out, you should register to our limited preview, which we announced. The link is on the stage. We should start to onboard customers in roughly 3-4 weeks. So if you're interested, just let us know. Literally, when you sign up, I get an email, so feel free.
All right, just to wrap up very quickly. So we have a proof of concept playbook to help you do a proof of concept of ATA, but you've seen how easy it is to deploy, so don't be afraid to start. We've got the links to the sizing tool in our documentation. We've got a simulation playbook as well as that suspicious activity guide, and we have a TechNet forum as well for questions. There is another session that starts at 12:30, which we'll do, it's called Analyze the Anatomy of an Advanced Attack, which will go through an attack and show you how ATA finds it. So if you're interested in the specific detections, you can do that. There was a session yesterday about Azure ATP, and there's a hands-on lab at Ignite, so you can try it out. Don't forget to email the session. They make us put that slide in there. And with that, if anyone has any questions, please come to the mics.